Hello, welcome to Algebra 1. We're starting our fifth learning target, which is really the first one of the semester, but we are going to learn about inequalities. It's going to be a lot like equations, both normal equations and line equations, but slightly different. So here we have the beginning of the notes, and we're going to end up graphing inequalities on a number line. I'm going to go through each of these four inequalities. Hopefully you've learned them from previous years, but if you haven't, here they are now. So the first one is less than, and less than means the number smaller than that number, and so we graph it with an open circle and the arrow to the left, the little blue drawing there on the left. The next one is greater than, and that means all the numbers that are more than that number, and so we have that with an open circle with the arrow to the right. Next one is less than or equal to, and that means all the numbers below that number, but maybe also that number, and so we show that with a closed dot or a filled in circle and an arrow to the left. And then the last one is greater than or equal to, and so that means all the numbers that are more than that number, but it could also be that number. And so it's a filled in dot and arrow to the right. These are things that I hope you have learned before, and I'm here to help remind you. So I've got a first example that's already worked out for you. We have to graph x is less than -2, and the graph is, in fact, right there. That's right there. Okay, so then let's move on. Here's another example, example 2. X is greater than or equal to -4. X is greater than or equal to -4. Let me try that again. X is greater than or equal to -4. And so that means we're going to have that closed dot, arrow to the right, at -4. And there we have it. Okay, now, example 3 I'm going to do for you here. It says x is greater than or equal to 3. And so I'm going to have a closed dot, but first, because it's greater than, I'm going to have the arrow to the right. And then because that little equal to line underneath, solid dot. So those are the two things. So, solid dot. Solid dot at 3, arrow to the right. Next example, example 4, it says, the way it's written right now, it says 0 is greater than m. That's not actually very helpful for us. It really helps if you rearrange it so that the variable is first. So the way you do that is kind of flip everything around, but what you need to notice is that the inequality symbol itself has flipped around. So the m is first now, and the number is last. Now we can compare it, and since it's a less than, that means the arrow is going to go to the left, and we're going to have an open dot because there isn't that or equal to line underneath. When that is missing, it's an open dot for the graph. So here we go. We have an open dot at 0, and the arrow goes to the left. Those are some quick examples. Now, what I'd like you to do is try these two examples on your own. The best way to do this if you're watching the video is to pause the video and try them, 5 and 6 in this case, and then unpause the video and check your work. I promise to wait for you if you pause me, and then I'll still be here when you get back. Go ahead and pause. So let's see what you got. For example 5, you really want to turn that around first. That turns the inequality around also, so it begins looking like less than or equal to. It turns into greater than or equal to. And then because of that, the arrow goes to the right, and we will have that closed dot, that solid circle thing. All right, so we find 1 on the number line, solid circle, arrow to the right. Example 6 does not get turned around because it's already in the correct order. We're going to have the arrow to the right, and we're not going to have the closed dot because there's no equal to line. So we're going to have an open dot. All right, so find negative 2. Go ahead and make that graph to the right. That's great when it's already solved, but we actually need to solve the inequalities, much like solving equations. So the way to get that done is to go ahead and remember one trick, which is when you multiply or divide each of the sides by a negative number, and only negative, then you have to switch the inequality sign. So you'll see some examples where we switch and some examples where we don't switch, and I'll highlight why that is. Here's example 7. It says negative 2x greater than 10. Well, we're going to have to divide by negative 2 because that's negative 2 times x, so you divide by negative 2. And when you do that, you have an x left over and you have a negative 5, 10 divided by negative 2. However, here we divided by a negative number, and so we're going to need to flip that inequality sign around. Now look at example 8. It says 2x less than or equal to 10. So since it's 2x, we're going to divide by 2. So we're going to have x and we're going to have 5 because we divided by 2. But this time we did not divide by a negative number. We divided by just a positive 2. And therefore, the inequality sign stays the same, less than or equal to. All right, let's look at a couple more. Here's example 9. Negative x divided by 2 less than negative 10. Now, there may be slightly different ways you've learned how to solve this, and it all works out the same in the end. My version is this. Since it's divided by 2, I'm going to multiply by 2, and that leaves me with negative x less than negative 20. Now notice I multiplied by 2, by positive 2, so the inequality did not change direction. However, I'm not done yet because it says negative x, so I need to divide both sides by negative 1. You might have learned multiply by negative 1. It actually ends up being the same thing. And since I divided by negative 1, it becomes positive 20. But because it was that negative number I divided by, that needs to turn the inequality sign around into greater than. Now, look at example 10. Here we have x plus 5 less than negative 10. So it's x plus 5, so we'll need to subtract 5 from each side. And that's negative 15. Now, it looks like we did some negative number magic here, but this is not multiplying or dividing, it's just subtracting. And since we just subtracted, the inequality never changes for adding or subtracting. Only changes for multiplying and dividing, and even then, that's only when you did the multiplying or dividing with a negative number. Okay, here's example 11. X minus 5 greater than or equal to negative 10, so we have to add 5 to each side. And so we have x and we have negative 5, and the inequality did not change direction because we added. And adding or subtracting, the inequality never changes direction. Example 12 is a little trickier. It shouldn't be overwhelming, but you should look at that and say, oh yeah, that's more work. And it is. So again, there's different ways you might have started this exercise. I'm going to just do the distributive property first. 3x plus 15 minus 2 less than or equal to 4. And then here I'm going to combine the like terms. So 3x plus 13 less than or equal to 4. And then if you go ahead and subtract 13 from each side, 3x less than or equal to negative 9. All of that does not change the inequality sign because so far I've not multiplied or divided by anything, and I certainly have not yet multiplied or divided by a negative number. So now I'm going to go ahead and divide by 3. So I had negative 3, but I divided by a positive 3. The answer ends up negative 3, but the action, the verb, is dividing by a positive 3. And so the inequality does not change sign. The inequality does not change direction. Okay, so again, here are a few for you to try. Now, notice here I've asked you to do two things. First, solve the inequality, and then also try to make a graph with your answer. Here's probably what's best is if you try 13 and 14 on your own, again, pause me. I'll still be here when you come back. And then check them. So would you please try 13 and 14 on your own? Okay, so let's see what happens here. On 13, the best way probably is to add 2 to each side, and that makes x greater than or equal to 3. Now, if we're going to make a graph out of that, we're going to need our solid dot at 3 and an arrow to the right. For example, 14, we're going to divide both sides by 6, and so we'll have x less than 4. And that means we're going to have an open dot at 4 and an arrow to the left. So now that you know and you've seen what I'm trying to get at with solving and graphing, would you please try 15 and 16 on your own? Again, go ahead, pause me. I'll still be here when you get back. Okay, so for 15, what's going to happen? We're going to subtract 2. We have 9, and then divide by -3. And then when we divide by -3, notice how the inequality sign switched direction. That's important. So it turns into a less than or equal to. And so -3, and then an arrow to the left. Okay, so for example, 16, adding 7 is probably your first step. And then my version is multiplying by 4 first, and then dividing by -1. And when you do divide by -1, it changes the direction of the inequality symbol. And that's the important thing we're trying to hone in on here. Okay, that's a few examples. I hope you feel like you've got a pretty good beginning idea of this, and then we've got some practice for you in class or on the website. So thank you for watching, and please let me know if you have any questions.